Okay, so let's talk about this function. This function happens in GRE quite often, and it's quite confusing, especially when you're considering the one. The really funny part, because all the positive and negative exponent give it as at the intersection of 1. It's intersect at 1 as you can see. So I give it several examples. For instance, y equal to x straight line, y equals to x squared, y equals to x cubed. As you can see, before 1, the x squared grows faster than x cubed actually, and after 1, the x cubed grows faster. That's the thing you need to keep in mind. And similar things happens to the fraction exponent. N equals to so that means cube root is cubic root give you a faster growing before 1, but it's grows slower than the square root after 1. And keep in mind that x squared always give you, actually not just x squared, n equals to any even number, no matter positive or negative, will give you a positive number, which is kind of intuitive because x squared negative 1 squared is 1. So that's the case. Whenever you encounter those type of problem, I suggest you to draw a diagram like this. You just need to know those few. You just need, and if you have like greater than that, you just make it more steep and make this more slow growing at before 1, and you can just have the intuitive understanding of this plot. Will give you a really can make you find yourself really easy to solve the problem in terms of like greater than 1, less than 1, and there's an exponent like in this type of form. And sometimes you will encounter those type of problem. For instance, you have negative x, negative 1 over x, 1 over x squared, 1 over x cubed. So it actually behaves much easier in terms of before 0. So x negative 3 is grow below that, below the green line, which is negative 2, and it's below negative 1. And keep in mind the green line, both positive and negative, will give you a positive result. Why? This is 1 over x squared. That's why I want to draw it now, because it needs some attention. Instead of here, because x squared give you a positive number. So based on those and those easy comparisons that you can use, if you have a greater or equals to b, then you can imply b less than equals to a, and then plus minus. Well, the same number doesn't flip the sign. Multiplied by a positive number doesn't flip sign. Multiplied by a negative number flips the sign. And if you get a greater or equal to b, b greater or equal to c, you can imply a greater or equal to c. A greater or equal to c, and thus you can use those those informations to imply the comparison in terms of that. The hard part after that will be implying those to a real life scenario and translate the question to numbers and equations.